So, in this video, we will discuss the delete operation on queue. So, as we already know that a queue has two ends. One is called front, which points to the first node in the queue, and the other end is called rear, which points to the last node in the queue. And the node addition can be done only at rear end, and node deletion can be done only at front end. So we will discuss now how this deletion of node at the front end can be done and how it can be implemented using C language. So first of all, we will see that we will illustrate the procedure of deletion by diagram. After that, we will, and after diagrammatic view, we will, from the diagram, we will write the code which is in C, and then after writing the code for deletion operation in Q, then we will implement that. We will write this code on the machine and will check the output whether it is coming properly or not. So today we will discuss the deletion operation on Q. So today we will discuss the deletion operation in Q. So if we here we will remember one thing, we will represent the queue in an array. Suppose this is an array which can store only 5 elements, 1, 2, 3, 4, 5. Each of the array elements can be accessed by index 0, 1, 2, 3, 4. And suppose the name of the array is ARR, which size is 5, that is it can store. Now Q is represented by this array where we can store at most 5 elements. Now suppose, so what can be the what could be the the diagram of Q at different conditions. Different conditions means what? Suppose the node is full, that Q is full, that means there are 5, for the Q size, Q can accommodate at most 5 elements, and all of the elements, 5 elements, are inserted into the Q. Suppose the elements are 10, 20, 30, 40 and 50. So this is one scenario when the Q is full. So this is the scenario when Q is full. So in that case, now we will consider the deletion operation for this case. Which case? Now when Q is full. So if Q is not full, then what happens? And if Q is full, then also what happens? That we will check, and then that will be written in C code. Now, obviously the front is a variable which contains the index of the first node in the queue. So this is the first node in the queue which indexes 0. So 0 is stored in variable front. And the location of the memory location reserved for this variable front may be like 1000. And there will be another variable which is called rear, which will point to the last node in the queue. That means that index of the last node will be stored in this rear variable. So it will be 5. Suppose the memory location it reserved for rear variable is like 2000. Now when the deletion operation will be done, so the node at the front node will be deleted. So the value of the then front, this variable will point to the next node in the queue. That means the value of the front will be changed after each deletion. Now, as we are changing the value of this variable, and for this deletion operation, we are calling a function. So within that function, the value of the front will be changed. So to reflect that change outside of that calling function, we have to use a pointer which will contain the address of this front variable. For example, suppose the pointer name is pfront, which contains the address of the front variable. So address of the front variable is 1000. So the content of pfront, which is a pointer which contains the address of the front variable, and the memory location which is reserved for this pointer pfront may be like 3000. And this is pointing to the front variable which contains the index of the first or front node in the queue. So this is the picture. And similarly, there is also rear pointer which we call as prear, which contains the address of the rear variable, because after insertion or deletion, the value in the rear variable will be changed. So to reflect that change outside of the calling function, we have to pass a parameter which will be a pointer, and that will contain the address of this rear variable. So what is the address of rear variable? It is 2000. So we are storing 2000 here. Suppose the memory location, so it is now pointing to the rear variable which contains the index of the last node in the queue. Suppose the memory location reserved for this pointer prear may be 4000. Okay, now this is the total diagram, and this is the diagram where the queue is full. So in that case, when the queue is full, there is no problem. We will extract the first node or front node value. Then we will change this we will change the value in front variable so that it will point to the next node in the queue. So what is that? So suppose for that, to extract the front node of the queue, we have to, as these all are integer value which are stored in the queue, so we will declare a variable int num, and in this num variable we will store the front